What are LED stages and are they all the same? In mixed reality, live performers and props are filmed inside an illuminated setup of LED walls, which are mapped with a corresponding virtual environment. This environment is rendered in real time to match the perspective of a tracked camera. The real stage and performers are lit correspondingly to the virtual scenery. In this way, real and virtual elements blend into single, comprehensive scene. Typically, LED stages are laid out as three-sided cubes, diamond configuration, or curved screens on top of a walk-on LED floor. There are variations and hybrids of these concave spaces, all of them typically open and aligned to the floor's diagonal as a main camera, or viewing axis analog to upstage-downstage direction. These setups include multiple elements: screens, slides, cameras, performers, and props. In this chapter, we will be using LED stage project made by Notch team as an example. It's available for you in a free download. Just go to notch.one/vp. A small heads up, since we are covering a lot of ground here, this chapter is split into 4 segments to match the workflow: technical preparation, design preparation, pre-production, location checklist, on location. All of these segments will have a number of practical tips and techniques that will help you with your LED stage design, development, and delivery. So let's start with the first step: technical preparation. Just because you can move your virtual camera in Notch to a perfect position does not mean the on-site camera can move to match that location. Physical constraints on site are one of the biggest cause of on-set changes to virtual scenes. While you can use Notch's live editing features to make adjustments on site, the best way to approach any virtual production shoot is to keep the physical constraints in mind when designing for the virtual set. For example, with a camera, is it going to be mounted on a boom, crane, or track? Knowing this and being able to design around it will greatly improve the shoot, guaranteed. Here is a little checklist of what to ask for from the studio or space when you head into pre-production. How big is the room? What lens will be mounted on the camera? Is there enough space behind the camera to move far enough back in case of a lens with a long focal length? Is there anything obstructing movement of a camera, such as other equipment, pillars, trusses? What is the distance from the edge of your LED stage to the walls from the room? What lenses will be used? At some point you will need to match the focal length of your physical and virtual cameras, and knowing this early informs your creative choices. Working with LED stages requires an overscan render, where you render a field of view wider than the actual tracking sensor will capture. This is to account for the latency in the tracking and video processing by the media server and LED processor. You should be provided, or you should request, either a scale or a fixed resolution that the scene will need to be rendered at. This will impact the performance ceiling of your scene. You will need a physical dimensions of the stage too, so you can build a pre-visualization and understand shot framing. This will help you review the whole scene, defining what is rendered on the LED and how the set extension blends with the LED surfaces. For more in-depth information about technical pipelines and requirements for virtual production, check the links below. These resources provide excellent deep dive into this subject. Now, let's talk about previs to support your design. When designing for green screen or LED stages, it's a good idea to build a 2-scale model of the key items in your Notch project. Let me mention some. Always add a LED stage or a green screen wall to your setup. If possible, model in or mark up the room you are shooting in. And of course, add key physical props that may be on the stage if you plan to use any. In my case, the scene has markup of LED walls and human figures. It is smart to parent these elements to a null, execute child node, or render layer, so you can disable them when you're done with your visualization. So in my case, I'm using execute child node. So anything that is parented to the execute child node is either rendering on screen or not, depending on the variable that I set in the execute child node. So why is it a good idea to add these elements to the scene? Well, adding them enables you to scale your virtual content correctly, as well as ensure that you're framing shots from the position the camera can reach. And it allows you to see the distances between the camera, the subject, and a LED screen, which helps you with the sense of depth. In general, it's essential to build your scene to correct scale, as virtual production depends on the 3D world matching the scale of the real world. So let's talk a bit about greyboxing. Greyboxing is a technique where you create your scene using basic boxed geometry at the correct scale and basic materials. There are numerous advantages to greyboxing at the start of your scene creation process. Let me name you some. Greyboxing will help you understand the layout of the project, what can be seen by the camera, where the points of interest are, and where the details should be added. During this stage, you can start to look at the lighting you will be using. Should it be ray-traced baked lighting, dynamic real-time lighting, or a combination of both? Greyboxing the placement of the physical LED wall will help you define the range of camera motion you have at your disposal. Creating greybox assets will help you working in a team or outsourcing. Greybox scale assets can be used as a template to give to other artists and outsourcing companies to make into the final high poly models. Keeping the floor on the 000 axis and connected to a null helps you to make sure that your set design is grounded in reality and things will align on location. Now you have laid the foundations of the scene. It's time to get into the design. In this chapter we will talk about 3D assets and working with front and back plates. We'll then get hands-on with lighting and optimization workshops. So grab a coffee and let's get into it. When it comes to preparing scene for virtual production, checklists are your friend. One of the most important things to work out is which elements of the scene will be static and which needs to be dynamic. That is, which will move or be affected by motion in the scene. Any static element can have its geometry combined and also have its lighting baked. This speeds up real-time rendering and can often make or break your performance goals. For dynamic elements, you should make a similar list to optimize those assets and elements for real-time rendering as well. Doing this will also help you later when it comes time to expose those elements to a media server for real-time control. Now let's talk about 3D models and how to prepare them. Before you import any external 3D asset into Notch, you need to make sure they are real-time friendly. This means acceptable poly counts, proper UVs for light baking, the right texture size. The biggest favor you can do to yourself when dealing with 3D assets is keeping the poly count low. Think about where in the scene the object will be placed. Is it a hero asset? That will be close to a camera. Then a higher poly count might be necessary. Is it going to be one of the many in the background, perhaps even out of focus? Then it can have much lower poly count. It can possibly even be just an image. This is where ingenuity comes to play. See how low you can take it without losing image fidelity, and your performance monitor will thank you. Proper UVs matter especially when it comes to baking lights. Baking the lighting in a scene is a great way to increase performance. Unique UVs are essential to the baking lights workflow. Without them, this will not be an option. This will save you a lot of time and a lot of hassle. Trust me. When it comes to textures, again, consider the best places to add textures. What makes for a rich environment? Does the art style require it? Again, are the objects close to or far away from the camera? The golden rule is keep all the details around the talent, not on the ceiling where nobody is watching anyway. For texture sizes, keep in mind that a 4K texture is 4 times bigger than 2K texture. And all those textures, eGPU memory, and you guessed it, rendering performance. So we are going to dive into some workshops about all of these techniques shortly. Front and backplate elements are at the foundations of the extended reality setup. Simply told, the front plate is whatever goes in front of the talent and the backplate is what goes behind them on the LED screens. While they appear in the same XR shot from the camera's point of view, they are actually treated slightly differently when setting up your scene. Let's test the front plate backplate setup together. In this tutorial, we will talk about a render layer node and its use for virtual productions. The render layer node renders all of its child nodes and their subtrees to a separate composition layer within the scene. When used in virtual production projects, the composite output position property allows you to choose if the render is positioned on the left or right-hand side of the screen, akin to frontplate backplate setups. Frontplate and backplate setups are a way for a designer to define what elements will be visible on LED screens and what elements are going to be shown and composited into the broadcast feed as augmented reality while containing it all in one coherent scene. When preparing a virtual production scene in Notch, the designer has to define what is the front plate and what is the back plate. And that is done by sending the signal to the left and to the right, thus arranging backplate to one side and front plate to the other. From there on, media server can take over this arrangement and distribute the signal to the front plate and the back plate accordingly in its internal system. In this example, we have backplate and front plate set up to render side by side in full double HD width in the viewport. This is done just so we can see better what is happening. When we are working on our designs, we don't need to double up our resolution in width for it to be read correctly by media server. Bespoke media server will do this calculation automatically internally, so you can keep your original scene settings at all times. So with that said, I'm going to change the current resolution to a more conventional 16:9, 1920 by 1080 resolution. So I'm going to go for Project, Settings, Rendering, and I will type in 1920 on the width. And now I will head to the root and I'm going to change the output render layer side by side to output composite. For the purposes of this tutorial, I will be using this template, and you can find this template whenever you turn on Notch. So when you're greeted with a hello screen, make sure to go to templates and scroll to the bottom. You will find virtual production simple template. So this is exactly what you see in front of you now. Instead of talking about all these nodes here in the scene, I think we should start things a little bit more simple, and we're going to add a render layer and all the appropriate extra nodes as we progress. So I'm going to find the very same scene, but without the render layer. And let's talk about the nodes that we have available for us here. So we have a camera, we're looking through this camera right now. We have one spotlight, we have skylight, and we have several 3D objects. Here we have a human model, and here we have two walls and a floor. A little bit further down, we have a box, which is 1 meter by 1 meter size, and we have two text nodes stating Notch Virtual Production Template. So I think we can start things by putting these two text nodes under render layer. So I'm going to grab render layer now. I will connect it to the root, and I will disconnect these two text nodes, and I'm going to connect them through a render layer. As mentioned in the beginning of the tutorial, render layer puts everything in a separate rendering path, so we can preview that in the viewport. So now these two text nodes are rendered separately on a separate path. I can further illustrate that by adding a tint node. Notice what happens when I apply the tint node to the render layer. Only the nodes connected to the render layer gets the red tint. The opposite happens if I connect it to the root. So let's talk about different properties that we have in a render layer node. So the first option we have is layer blend modes. There's quite a few to choose from, but for this tutorial we'll stick with blend with alpha channel. Property beneath layer blend mode is alpha, so we can fade in and fade out all the contents of the render layer using this slider right here. After the alpha, we have composition order, so should we have more than one render layer, we can define how are they stacking and what is the consecutive order of them being rendered in the scene. Further down the line, we have onDef buffer. So this property right here makes sure that all the contents of render layer is rendered on top of everything else in the scene. In our case, since we're preparing this for the virtual production, this is definitely a needed tick box, so I'm going to go ahead and tick that on. Now I can be certain that anything connected to the render layer will be in front of any other items that are in the scene. Next property in render layer is deferred lighting enabled. So this is quite self-explanatory, just like we have deferred lighting on the root node. We have an option to turn it on and off for the render layer as well. There might be instances where you're working with something very simple like a 2D image. In that case, you probably wouldn't need deferred lighting, but since we're working with the 3D scene, this is definitely needed, so I'm going to leave it on. Further down the line, we have composite output position, so we can choose should it be composited to the left or right. In this case, we want to send our front plate arrangements to the right hand side, so I'm going to choose that. We don't see any impact just yet, and that is because we need to go back to the root node and change the output render layer side by side property from no output composite to output side by side. All of a sudden we see that a render layer is being rendered on the right hand side. Of course we can choose to send it back to the left, but we're going to keep it on the right hand side. As mentioned in the beginning of the tutorial, media server would understand this arrangement and it would distribute the signal as two 16:9ers side by side. So we're not obliged to add width to our viewport, that is just not needed. In most cases, while working with the virtual productions, you likely will be looking at the setup as a composite. But for the purposes of making this tutorial more clear, I'm going to go for the project, settings, and I'm going to add some width to my arrangement. So I'm going to make sure that we have double the HD in width. There we go. So now we definitely see the backplate and front plate arranged side by side. So let's come back to the list of available properties in render layer. We can change the background color. In majority of cases, you likely will just keep it black or alpha. And then we have different ways of previewing our render layer in the viewport. So we can start by previewing the contents, then we can see the RGB values, and of course we can see the alpha values too. You may have noticed that there's two inputs here on the side of render layer. So first one is affecting lights and the second one is excluded lights. So let's grab the spotlight and let's pipe it to the excluded lights property. As you see, this light now is excluded from the render layer. So the very opposite operation would be affecting lights. So you may choose to use one or the other in accordance to your design. By default, a render layer will take advantage of all the lights that are available in the scene. So the next thing that I would like to cover in this tutorial is color treatment. I'm going to grab a LUT that I have here in the resources and I'm going to connect it to the root. And now you can see that the color LUT is applied on the backplate, but it's not affecting the render layer setup. So the front plate is not working with this color LUT. In order for both back and front plate to have the same color grade, I have to grab a copy of this color LUT and connect it to render layer. Now, if I go to the root now and I change the output render layer side by side to a output composite, you will notice that by adding an extra color LUT, not only I applied it on the render layer, but I doubled up its influence because it's stacking twice on the render layer and on the root setup. So how do we fix that? Well, in every single color grade related node in Notch, we have two properties. The first one is apply to solid geometry only. I'm going to tick that on. And more importantly, apply to filled pixels only. So now we're not applying this LUT to the whole area of render layer. We're only applying this LUT where we have geometry filling the pixels. So this evens out the values and makes these color LUTs work hand in hand, delivering one coherent design. I'm going to switch back side-by-side view now. When working with virtual productions and backplate and frontplate, you might find yourself in a situation where you're not sure if the object should be in the backplate or frontplate. To address this issue, we have a separate node that helps out. That node is called Select a Render Layer for Child Nodes. So I'm going to bring that to the scene. I will connect it to the root. And I will grab this 3D box and I will pipe it through Select a Render Layer. There we go. And not much changed. And that is because I haven't defined what kind of a render layer should this Select Render Layer node work with. So I will grab this render layer and I will pipe it into the first input render layers. So now the setup is complete and the cube jumped from the backplate to the front plate. It jumped because we have an active property. When this node is set to inactive property, it is rendering through root straight to the shape 3D box. And once it's activated, it's thinking that this node, shape 3D box, is connected to the render layer. So basically this is a switch. Either it renders to the backplate, hence connected to the root, or it renders as a part of the render layer, thus to the front plate. So let's cover the rest of the properties that we have in a Select Render Layer for Child nodes. The second property we have here is modes, and we can choose either we see the children in the selected layer, or we can see them in both layers at the same time. I'm going to switch it back to children visible in selected layer. Then we have camera clip plane mode. I'm going to set it to in front. So now we have a slider that defines us where is the clipping happening. So this property defines at what distance should the object be sent to the backplate or front plate. Using modifiers, you could attach this property to your camera if you desire to keep it dynamic. I will further illustrate this clipping property by adding a sphere that is going to be turning around the center of this scene around this human. So I'm going to start off by adding a null. I will connect it to the Select Render Layer. This will be my pivot point and I will add a 3D primitive shape 3D. So now I want the shape 3D to be a little bit higher and in front of the object. And now as I will change the values in the heading, you will see that it's clipping either to the front or the back plate. Let's add a continuous modifier so we can see this animating. There we go. And let's attach it to the heading property. Let's give it a little bit more speed. And now as you see, as soon as it hits the set clip point, it either goes to the backplate or the front plate, depending on where we set that clip point. There might be instances where you will need more precision sending things to the backplate or front plate. For that, you can use bounds. So there's an input for a bound box. And by using this bound box, you can actually define where and what should be sent to the front or backplate, depending on the position of the bound box. Once you're done with your design and you are ready to send it out to a media server, make sure to double check the composite blend mode. In my case, it's already set to blend with alpha channel. By default, it's set to blend. Now, notice what happens if I preview the alpha of the composite blend mode set to blend. We do not contain alpha in this setting, so always double check and make sure that your composite blend mode is set to blend with alpha channel. As you see now, we definitely have alpha and we can composite these two things one on top of the other. So let's cover the most important points of this tutorial. First of all, make sure that you have render layer in scene and you have all the objects that you want to send to the front plate attached to the render layer. If you are not certain if one or the other item should be sent to the front plate or back plate, you can always use select render layer for child nodes to define that. In render layer, make sure to tick on depth buffer and deferred lighting if you are requiring a little bit more elaborate 3D work. Choose the left or right hand side for your front plate. And if you are using color grade, make sure to tick on apply to filled pixels only for the best results. And of course, as mentioned before, always double check if your composite blend mode is set to blend with alpha channel if you want to stack those two plates in media server. So now we'll take a chance to remind you that we changed the resolution of the setup only so we see things a little bit better. This is absolutely not needed when you are working on your virtual production scene. So I'm going to switch it back. So project, settings, rendering, I'm going to set it back to 1920 by 1080. And now I will head back to the root, and on the output render layer side by side, I will change no output composite. So this concludes the tutorial. This scene is ready now to be sent out to media server, and you can do that by going to project, compile block for media server. Let's talk about creating efficient, effective lighting for virtual production scenes. As discussed briefly before, dynamic lighting can be performance heavy. So let me show you a few tools and techniques that will help you reclaim those precious milliseconds. A good lighting setup will have static lights that are baked into the scene's geometry with additional dynamic lights on top. Using baked lighting reduces the rendering time of your scene. Somewhat simplified, baking removes rendering overhead from the GPU itself and bakes that lighting as a texture into texture memory instead. Once you have successfully baked the static lights, you can still add dynamic lights to add life and detail into your scene. To do that, there are two things you need to learn, which is how to use the baked lighting node and how to make baked light dynamic. Let's check out those things now. In this video, we will talk about light baking node and all of its properties. But before we delve into the light baking node, let's talk a little bit about UVs. So UVs are 2D image projections on a 3D model's surface. And it's very important to choose the correct UV mapping for your 3D models depending on a task that you are to fulfill. So in this case, we have two cubes. Both of them are exported from Cinema 4D. Both of them are exactly the same. The only difference between the first one and the second one is the UV map that is applied. So the first one has a non-unique UV map, which is tiling on every single facet equally. So basically, this texture of a brick is applied to the front, left, right, top and bottom, exactly the same. Now further here on the right, we have the very same 3D model, but with a very different mapping type. And in this case, this mapping is unique. This texture of the brick is actually wrapping around the model. Now let me illustrate this in a Cinema 4D, because I use Cinema 4D for all my modeling and UVing purposes. So I'm going to open Cinema 4D now. So here in Cinema, I'll start by creating a primitive, and I will make this primitive into a geometry. So right click, make editable. As soon as I do that, I get the UV tag assigned automatically. So if I navigate now to the UV edit, I will see that any side that I choose is exactly the same. It's represented by the very same tile. Even if I choose all of the sides at once, all of them are referring to the same texture coordinates. And that is exactly why in Notch we see this brick texture applied equally to every single facet of this cube. But if I come back to Cinema 4D and change the mapping type from tiled to a unique mapping, for instance cubic 2, this brick texture will not apply the same on this UV anymore. So let's grab this texture and apply it on this setup to further illustrate that. There we go. So now every single facet is unique. Every single facet is different and it's taking different areas from this texture map. So let's come back to Notch now and let's talk about the reason why is it important. Well, since every single facet here is unique, if we're dropping a light on the model and if there's a shadow being dropped on one of the facets, this shadow will be baked into this specific location of this specific facet. And that is because this wall has a unique coordinate for texture mapping. Now, if we were to do the very same thing on this cube with the tiled texture sheet, the baked lighting would just not work out because the very same baked lighting would be applied on every single wall equally, and that would look just plain weird. So now we know the main differences between the non-unique UVs and unique UVs. Now, bearing in mind that there is good reason to use both of these techniques in your projects, I will mention that you have an option to use one and the other on the very same 3D model because you can assign multiple UV maps. So here I have a third cube, which is as well exported from Cinema 4D. It's just in this case, instead of having one UV pass, it actually has two. So here under the UV set bracket, I have color texture UV set drop down and I can choose, should I go for non-unique or unique UV map? In fact, we have an option to apply both of the UV sets and use them for different purposes. For instance, color texture can be non-unique and diffuse texture map can be the unique one. And as soon as we set our tiled non-unique UV map on the color texture set and the unique wrapping UV set on the diffuse texture UV set, we can take full advantage of light baking node. So I'm going to grab a light bake node from node list and apply it on this 3D model. Using bake lighting to object node is as easy as that. You just connect it to the 3D model that you want to bake, and then you address all the settings in the node in accordance to your needs. So let's talk about all of these settings one by one. Well, first of all, you have Bake Now button, but we will not touch it just yet because we want to change some parameters here. And then we have Pile Append property, so here we can choose how do we want to name our light maps. And then we have a number of refinements available for us. Default is 50, so I'll just leave it at 50 for now. Then we can choose to preview the rendered texture, so we'll come back to the setting. Here we have a width and height of the texture, and we can input any value that we feel is befitting our setting. Then we have bit depth property. I will leave this property unchanged. I'm very happy with 16-bit. So let's talk a bit about 16-bit setting and why is it good to keep it as a default. 16-bit is important when baking light that has higher dynamic range or a brightness that is more than 1. If you don't use 16-bit on HDR scenes, the lighting will be duller because the texture format won't support the higher ranges in the light. One more thing to note about 16-bit textures, they also have a larger file size as they use the alpha channel to calculate the light brightness for the texture. So just keep that in mind. Then further down we have post filter light map. This property right here blurs our light map a little bit. So basically it decreases the necessary iterations or necessary steps of refinement if you're using path tracer and allows you to achieve better results with less refinements. So we will come back to this setting as we progress. Then we have disable baking pass-through option. This is most applicable if you have a lot of bake lighting nodes and you want to bake them all at once and you just want one of them to be bypassed. So this would be the very setting you would tick on. And then we have a UV channel selector. And here we have a couple of options: color and diffuse light map. And this setting right here directly correlates with the settings that we've chosen for this 3D object. So the first property is color texture UV set, and it's set to non-unique. And then the second one is diffuse texture UV set unique. So for our light baking purposes, we definitely want to use UV channel diffuse, so we can bake our lights on this unique UV map. So let's double check. The first pass is color texture, we don't want to touch that. The second pass here is meant for light baking, and it's set to unique. Great. So let's come back to the bake lighting node. I will press on the bake now button, and here I have several properties available for me. So first of all, I can make some presets if I'm gonna be using the same settings time and time again. Then I can choose export type, but I'll leave it at default. I can choose the location of export, so perhaps I should put it on a desktop, for instance. And again, I have the very same property of refined passes, just like I had in a previous tab. I'll hit OK. There we go. Light is baked now. Let me draw your attention now for a second to the resource tab. Here on the top left corner, you will see that now you have a new subfolder in the resources called baked light maps. So the light that we just baked in using the desktop directory now is actually included in our Notch project file, and the texture that we have on our desktop we could easily delete because it was only necessary for the duration of the bake. So basically it's a proxy location. As soon as the baking is done, the baked texture is allocated in the resources and included in your DFX file. Okay, so let's move on now and preview the baked texture. Since we were using unique UVs for this light bake, every single facet, every single wall has a different shade. And actually here we see a little shadow that is being dropped on this side of the model. Now just for the demo purposes, in the bake lighting, I'm going to choose another UV channel. I'm going to choose color. And as you recall, in the color channel, we set the non-unique UV map. So let's see what happens now. There we go. The texture is baked. Every single wall of this cube got the same bake. And since it's non-unique, we cannot really see the light map anymore. So I'll change this back from UV channel color to UV channel diffuse. I will rebake it. So let's apply this technique on a little bit more complex setup. So I will disable these 3 cubes, and I will enable this 3D object that I brought in from Cinema 4D. Now let's grab this material. This material is set to default settings. There's nothing changed in it. And let's apply on this 3D object. So this material too is using the very same brick tile texture, and this 3D model, just like our last cube, has 2 UV sets available for it. So if we scroll a little bit lower to the UV set bracket, you will see that there's color texture UV set, UV channel 1 and UV channel 2. So here we can choose for the color texture, do we want to use a tiled texture, non-unique, or do we want to use the unique one? Now I think for the color texture, let's just keep the tiled non-unique, and of course for the diffuse texture UV set, let's set it to second channel unique, because this is exactly what we're going to apply when we're going to use bake lighting node. So before we bring in one more bake lighting to object node, let's just make the scene a little bit more interesting by enabling path tracer. So I'll just navigate to the root and I will enable ray tracing. There we go. I already have path tracer in the Nodegraph. It's set to its default settings. Aside of the path tracer, I have RT refinement. An RT refinement node is set to 50 passes. Its default setting is 1000. We don't really need 1000 refinements here because we will bake our lighting and we will set these properties directly in a bake lighting to object node. So I'll just leave it on 50. This is good enough number for us to preview things. And of course, let's address the basic lighting that we have here in the scene. So we have a skylight that lights up the whole scene. It's working together with environment image. An environment image is powered by this HDRI. And here we have one spotlight that produces a little bit of a shadows for us here. Right, so with all this said and done, let's bring in a bake lighting to object node. Let's connect it to the 3D object. And now let's just go through different settings that we have in the node. In this case, I think we should increase that number of refinements. So let's just give it a bit better quality. Perhaps let's go for something like 200 iterations. I think we want a little bit bigger width and height. I don't have to calculate this manually. Notch can do that for me. So let's go for times 4 setting on the width and ×4 setting on the height. There we go. Let's leave the 16-bit depth. And let's enable post filter light map. That will just blur out all the small inconsistencies and will flush out our light map. So let's stick that on. Now in a UV channel, let's double check and make sure that we have a second pass of UVs chosen, so diffuse light map. And let's double check that on a 3D model. Yes, diffuse texture UV set is set to channel 2, a unique UV mapping. That's great. Let's come back to the bake lighting to object node. We're more than ready to bake. So I will click on the bake now button. I will drop off this texture to the desktop, hit save, and give a moment for this to bake. Great, our lighting is baked in. There is no need for us to have any of these lights in the scene anymore, so I can just disable them. And actually I can disable the ray tracer as well. We don't need any of the light nodes in this scene anymore because all of the lighting is contained in this 3D model as a diffuse light map texture. Let's look around this model. Yeah, I think the quality of the shadows is rather nice, so our choice of 200 refinements definitely paid off. Now, depending on the complexity of the geometry that you're using and your scene, you might want to choose a bigger number of refinements and a bigger number of the texture. But I would say that in majority of cases, having a 4K texture for a light map is probably just fine. Now, before we move on and talk about applying dynamic lights on the baked lighting, let me just show you this 3D model in Cinema 4D and show both of the UV maps that are applied on it. There we go, this is our 3D model, and as you see there's two UVs. As mentioned, one is tiled and overlapping, and one is unique that is being used for the bake lighting. Let's preview that in the UV editor. Right, so this is our first one. Let's pan out. Yep, definitely overlapping, definitely not unique. And here's the second one. And I can see every single facet laid out in available UV space very, very neatly. Assigning multiple UVs might differ from one tool to another, but I'm going to show you how to do this here in Cinema 4D. So I will delete this unique UV, press Ctrl, and drag it out. Now I have two UVs. So I will choose all the geometry available here on the second UV by pressing Ctrl A. And with all of this geometry selected, I will choose a cubic projection mode. Let's just zoom in a little bit closer to see how it looks. So I see that all of these UVs are actually overlapping. So to fix that, I'm going to go for optimal mapping, and I will apply this property. And now we have a unique UV map. Every single surface is separated and has unique coordinates. In fact, I could reduce the spacing a little bit because 2 is a little bit much. I can definitely increase the size of every single tile and decrease the space in between those tiles. Let's apply. Obviously, the smaller loose gaps you have in between the surfaces, the more pixels you actually squeeze into every single facet of this 3D model. So my general advice would be to make sure that you are not wasting any pixels or as little pixels as you can for all the gaps in between the UV coordinates. But this is good enough for demo reasons. And as you see now, we have two UV sets and they are both ready for use in Notch. So the tiled one can be applied as a color map and the unique non-overlapping one can be applied as a light bake. So let's come back to Notch. There is one more thing that I want to showcase in this video, and that's applying dynamic lighting on your baked lighting setup. So let's grab a light. So if I grab a new light, connect it to the root, position it in a viewport, as you see, it's not reacting, it's not really lighting up the scene. And that is because this bake lighting to object node is disregarding the new light that we created. So let's make sure that it's being respected and it's working hand in hand. In order to do that, we have to make sure that bake lighting to object node knows what lights were baked in. And that is a good reason for you to keep all the light nodes in the scene, even if you baked the lighting and you're done with them. So I'm going to grab the skylight and pipe it to the first input, bake lighting to object baked lights. And I'll do the same with the spotlight that we've used. And as you see now, this dynamic light is now actually respected by the bake lighting node and is working dynamically with a baked-in lighting. Let's enable shadows here. There we go. Now, before we finish, I'll just mention one more property that is extremely handy if you're working with a lot of 3D geometry and you need to bake a lighting to a lot of 3D objects. If you right click on the bake lighting node, you will see that the last option in the node is bake lighting to object option. And here you can choose bake all lighting nodes or bake selected lighting nodes. So in essence, you have a very nice control of how many bake lighting to nodes you want to use at once. You can bake them all, you can bake selected, or you can of course choose to bake them one by one, depending on your scene, depending on what you're building. And I think this concludes our conversation about light baking. Baked lighting is an integral part of optimization, but there are a ton of other tools in Notch that help you hit the target frame rate, preferably with leaving some rendering overhead to the media server as well. Let's go over some of the most important ones now. In this video, we will talk about Freeze Geometry Node and how Freeze Geometry Node can help us out with our scene optimization. So let's get a little bit more familiar with the scene, and then we can move on to a conversation about Freeze Geometry. First of all, here we have a little bit of geometry, and all the geometry points are split to 4 brackets. So we have our walls, we have our screen arrangement here in the center, we have a floor, and we have 2 3D meshes representing a human scale in this scene. We're lighting the scene up with several area lights, and they are all ray traced. Here at top we have several post effects helping us out a little bit with the color processing. So now we're ready to talk about Freeze Geometry Node. So first of all, I'm going to bring it to the scene. Let's expand the Nodegraph and let's zoom in a little bit closer to the Freeze Geometry Node. So working with Freeze Geometry Node is rather simple. All you have to do is connect it to the root, and then you can pipe in all the geometry that you want to freeze to its first input geometry source. So I will mark up all of this bracket, all of the walls, and I will pipe it to the first input. There we go. So the geometry is now accounted for, and as you see, we have a visual indication that it's working with Freeze Geometry Node. All of the meshes that are piped to the Freeze Geometry Node got this snowflake icon indicating that they are frozen. All of the materials that we're using with these meshes are preserved and respected by Freeze Geometry Node. Adding Freeze Geometry Node or nodes to your scene should be one of the last processes of optimization, because by adding Freeze Geometry Node, you are locking all of the meshes that you connected to it. So these meshes are now locked in space, they cannot be moved anymore until we unfreeze them and change their position. So how do we benefit from Freeze Geometry Node? In essence, Notch likes 3D meshes that consist of more or less 20,000 polygons. So if you have some 3D geometry that is below that threshold, it's suboptimal for Notch processing. So if you're not planning to animate that geometry and it's going to stay static, it's a great idea to grab all of those meshes and feed it to the Freeze Geometry Node. By doing that, you enable Notch to think about all of this geometry, all 8 nodes, as one unified mesh. Number of nodes in a node graph directly correlates with the CPU performance. So the smaller the number of nodes you have, the faster the performance from your CPU you can expect. By now, we're definitely familiar with a bake lighting to object node, and that node applies on Freeze Geometry as well. Let's grab that. So instead of connecting bake lighting to object node to every single point of geometry here, I can connect it directly to the Freeze Geometry. Every single 3D object here has unique UV assigned to it. And all of those UVs are actually respected by Freeze Geometry Node. So we can definitely use Bake Light to Object Node to bake out a light map that combines all of these elements, all of these walls. So let's do that together. I'm going to go for Bake Lighting to Object Node. I will increase the number of refined iterations, so let's say 200, and I'll make this texture bigger. So I'll make it 4 times bigger. So I'm putting a small math formula times 4. There we go. We definitely want to post filter light map. And I propose we drop this bake on the desktop. There we go. Okay. So the baking is complete. Let's preview the rendered texture. As you see, available texture space was divided into 9 brackets. 8 of them are filled in with light maps. And that is because we're using 8 meshes here. So Freeze Geometry node considers every single available mesh and distributes it in the available space. In this case, it divided the space into 9 squares and it filled 8 of them with available geometry with unique UVs. We're not locked off to any specific number when it comes to the number of available operators. We can freeze as many meshes as we need to. In fact, I can grab every single mesh that I have here and put it under one Freeze Geometry node. So I'll do that. So for now, I will delete this big light to object node. I will move this Freeze Geometry node a little bit to the side. I think I'm going to leave it here so we see the linking lines a little bit better. And now I will connect every single 3D object that I have in the scene to this one Freeze Geometry node. There we go. So all of this geometry is now frozen in this Freeze Geometry node. So let's grab another bake light to object node. Let's connect it to the Freeze Geometry and let's try to bake out another light map. Now I'm going to stick with 200 setting. However, since we're attaching so many meshes here, I think we should increase the width and height of this texture. I will go for something like 6K. There we go. We definitely want post filter light map. And again, let's drop this off on a desktop. So our bake is complete. Let's preview the rendered texture. So we have 16 meshes here in the scene and they are all represented in 16 brackets or squares in this rendered texture. Let's untick the show to render texture and let's turn off all the lighting from the scene. There we go. And now I'm going to disable the ray tracer as well. So when I start the playback now, I see that my performance numbers are fairly sophisticated. So we have just unified all of these 16 meshes to one mesh and we baked it all out as one light bake. Of course, you can take all your available geometry, send it to Freeze Geometry and then bake one lighting map from all of it, but I don't think this is the most optimal workflow. I would suggest to go for smaller groupings, especially bearing in mind the optimal polygon count, 20,000 polygons. So I think I will disconnect all of this geometry from this specific Freeze Geometry node and I will rebake the scene 4 times. The walls, the screen arrangement here in the back, the floor, and the human size references as 4 separate frozen geometry bakes. But before I do that, I want to showcase one very important thing about Freeze Geometry node. When you are using Freeze Geometry node together with Bake Light to Object node, not only you are locking in the viewport position of this geometry, but the position in the light bake texture as well. So if I start to move around these nodes in the Nodegraph and restart the playhead, you will see that all of our light bakes are off. And that is because we've just changed the arrangement that was assigned by Freeze Geometry node, and the light bake texture does not align with the available geometry anymore. So definitely bear that in mind. If you have chosen to freeze the geometry and bake lighting from it, do not reposition the nodes anymore. You should keep them as they were originally. However, there might be a situation where you just need to reposition the 3D models either in a Nodegraph or the viewport. And that's completely fine. All you have to do is rebake the textures. And that is yet one more reason why I would split this scene to 4 smaller subgroups. So now I'm going to delete the Freeze Geometry node. I will delete the Bake Light to Object node, restart the playhead, enable the lighting, because of course we need this back, and I will enable the ray tracer. There we go. So now let's bring in several Freeze Geometry nodes. So there's our first one. Let's connect it to the root. Here's our second one. Third one, and the fourth. And now let's feed all of the available geometry to the newly made Freeze Geometry nodes. There we go. So now let's add Bake Lighting to Object nodes to the graph. Okay. I think I will set up specific parameters for the first one, and then I will just copy out and distribute it amongst the other left freeze geometry nodes. So I want the texture size to be a little bit bigger, so I will go ×3 on both width and the height. I want a little bit more refined, maybe 150. I will enable the post filter light map, and I will make sure that this goes directly on my desktop. I will not hit OK here because I don't want to start rendering just yet. I will hit cancel, and I will copy this node, paste it, connect it to the second one, to the third freeze geometry, and to the fourth. So in the previous video, when we were talking about bake lighting to object node, we've discussed an option to send all of the lighting nodes to baking at once. So I'll do that. Our baking is complete. Let's preview the textures. So this is our walls. This is our screen. And here we have our floor. And this is our human reference models. Great. I can definitely turn off the lighting. And as you see, scene's performance is back to very, very nice numbers. However, let's come back to the conversation about repositioning 3D geometry. For instance, what if I need to grab this model and position it here on the left? Well, in order to do that, first I need to unfreeze the geometry and then reposition it. So I will click on a freeze geometry. I will press Ctrl+1 to disable it. I will move the geometry, and now I can enable the freeze geometry back. And now, as you see, the light map textures do not align anymore, neither on this human shape, neither on this floor. So obviously we need to rebake the floor and the human shapes. So I will move these light nodes a little bit higher up. I will make sure to turn back the lighting, so ray tracer and all of the area lights. Now I will select both bake lighting to object nodes, right click, and I'm going to choose bake selected lighting nodes. And here we are, our light baking is complete. So let me just recap the most important points of freeze geometry use cases. Freeze geometry reduces the number of nodes being used in the scene. This is very important if you have a lot of geometry and that geometry is in a small numbers. By combining geometry to chunks closer to 20,000 polys, you are helping Notch a lot with processing. And of course, node number directly correlates with your CPU performance. And any millisecond regained back from your GPU or CPU will help you out further in your virtual production process. In this video, we will talk about material caching. This is a great optimization technique that allows you to reduce node count in the Nodegraph, thus increasing your CPU performance. And it definitely assists your GPU as it locks up the processing of all the post effects and all the generators that you may have applied on your materials. Notch saves the cached material as a DDS file and stores it directly in your resource panel. DDS is a Microsoft container file format for storing data. It is beneficial for us to use it because it reduces the file size significantly and it can be decompressed in hardware by your GPU. In fact, it's very smart to convert all your textures to DDS format. And Notch provides you with an option for such conversion directly in the resource panel. With that said, let's get hands-on and let's talk about this scene and nodes in it. So here we have rather complex material setup with a lot of externally linking video loaders containing different textures. So all of this external texture treatment is a big overhead on our node count and on our processing. We can get rid of all of that just by caching in our material. And the process is rather simple. So you right click on the material and the last property in the material options is cache material. As you see, you have several choices. You can go for cache all materials or cache selected materials too. In this case, we have only one material, so we will go for the first option, cache material. As soon as the material is cached in, I see that there's a new bracket in my resources and it's called baked material textures. So all of the texture maps that were altered, for instance, this color map and this roughness map, they are combined and they are stored as new files in a DDS format. So that means that I can get rid of all of these nodes now because they are completely unlinked from the material node and my node count overhead is significantly smaller. So the texture maps that were not altered by compositing or post-processing, they're just brought in to the texture dropdowns as they were. So Notch is caching in only the texture maps that were altered internally in Notch. Now, mind you, this is a destructive workflow, so if you cached in a material, you cannot revert back to the pre-cache state. So that's just something to keep in mind. So I would always suggest caching in materials as one of the last steps of your optimization process. And of course, having a backup of your work file is always a very, very sound choice. In the beginning of the video, I've mentioned that you can convert all of your existing texture maps to DDS format. So let's explore the resource tab a little bit and let's talk about it. I see that majority of my textures are in JPEG format. And I can actually see some extra information about these textures right here in the resources. I see their pixel size, I see their color space, I can read out the size of the texture, and I can see how long does it take for it to load up to Notch resources. So how do you convert the existing texture that is in JPEG or PNG or any other format, and how do you make it into a DDS file? Well, you can do that just by right-clicking on the texture that you want to treat, and then you will be brought into the options property. And here you have three choices. Either it should be RGB, RGBA, or grayscale. Now I see that all of these textures are RGBA, so I would choose the property compressed to DXT5 RGBA. Now you might be wondering, what is DXT? DXT is a texture compression format and it's widely supported and used on current graphics hardware. Files converted via DXT conversion will stay compressed in a video memory of GPU, allowing you to save space and load up time. Thus you will be able to use bigger textures without added weight to the work file or increased load time. So let's go for it and let's just convert. There we go, conversion is done, and I definitely see that the size of a texture went down significantly. So we can repeat the process with all of the rest of the texture maps. However, I would not suggest to do that with HDR images or normals. They are calculated and treated a little bit different, so I would just leave them as is in original format, whatever that might be. So let's convert the ambient occlusion, displacement, and roughness. So we've optimized our node graph and reduced the number of nodes in the node graph, but we could optimize our resources as well. Here we have a couple of texture maps that we're not necessarily using with this material. For instance, we're not using the albedo anymore, as we just cached in a color texture. We did the same process with a roughness map as well. So instead of deleting them one by one, we can just right click and go for remove unused resources property. And that concludes our conversation about material caching. In this video, we will talk about Performance Panel. The Performance Panel allows you to estimate the performance of your project on a target GPU or media server. Let's enable this panel. So let's go to View, Performance. So my Performance tab is already estimating. If yours is not, that means you haven't ran the Notch benchmark test. So let's run Notch benchmark test together. So let's go for Help, Benchmarking, and let's run benchmark. As soon as you are done benchmarking, you will see that this panel becomes active for you as well. So the top half of the panel allows you to see the performance of your current machine. Specifically, it measures the time taken by the GPU to render each frame, and that is shown in GPU milliseconds. The bottom half allows you to select a target system and estimate the GPU time per frame for the current project running on that GPU or media server. For this panel to work, you need to have access to internet, as data for estimations is drawn from the online database that is constantly updated with all new GPUs and media servers that can run Notch Builder and Notch blocks. It is important to note that performance prediction is based on the resolution of render on your current machine. So for the accurate reading of the data, you should lock your scene to specific resolution. At this time, resolution is definitely set to a float. As I'm changing the size of the viewport, my viewport resolution is changing accordingly. So let's lock the resolution of this scene. Let's go to Project, Settings, and under the Rendering tab, we have a property called Output Resizing. So let's set it to the second property, Scale Filter Output to Window. So this property right here sets the resolution to specific numeric values that you put in the output width and output height. Let's press OK. There we go. Now, regardless of what size of a viewport I have, the resolution is locked. Therefore, these numeric values are much more accurate. So let's talk a little bit more about the estimates for media server. Unless your media server has a sidecar GPU dedicated to notch rendering, your notch scene will be sharing the same GPU processor as the media server software. When rendering at 60 frames a second, the GPU has 16.6 milliseconds to do all the work required to render and present its content to the connected output device, LED panel, projector, so on and so forth. During this 16 milliseconds, the GPU has to perform activities for the media server software, uploading video frames, warping the projectors, do the camera tracking, as well as render any notch content you are playing in that particular moment. Therefore, the most accurate way you can plan for the expected playback performance of the notch block is by discussing it with the media server provider and calculating the full load on the server, including the GPU overhead. In this video, we will talk about Profiler Panel. You can track what aspects of the scene are taking GPU and CPU time by enabling Profiler. With that done, you will get a readout of a variety of notch processes under the hood and data about your nodes in the scene. And how long does it take to render them out in GPU and CPU milliseconds? Let's enable Profiler. So it's here, just next to the nodes, the second tab on the right. Profiler, enable. I'll make this panel bigger so we can see it a little bit better. So here we can see frame begin property. That represents the total frame time. The left value is GPU and the right value is CPU. And here's a whole list of processes that are happening in the scene. As a general rule, the nodes that are more expensive to run computationally gets text on them as visual data. So you can quickly read out their values on a GPU and on CPU. So with that data available, you can make adjustments to your nodes till you get the performance you are targeting. It is worth to note that performance of your scene might drop a little bit while you're using Profiler. After all, it's an extra process that Notch needs to calculate. So for the most accurate read of the benefits of your optimizations, you should turn Profiler off, check the readout, and then turn it back on to make further adjustments. Profiler works via network too if you want to read out the performance of your exported block. We will talk about it more in upcoming videos where we discuss and try out network editing. In several previous videos, we discussed a number of optimization techniques and tools available in Notch. Let's put it all to practice and let's optimize this scene a little bit. Let's read out the performance now. Okay, so we are oscillating between 45 frames to 60 frames. We have 50 milliseconds on GPU and 15 to 8 milliseconds on CPU. Let's see if we can make these numbers better. I think step one should be double checking that all of the geometry is connected to appropriate freeze geometry nodes, and we're not overloading the scene with unnecessary bake light to object nodes and lose 3D geometry. So in the first panel floor, I see that there's 3 panels for the floor, which have their own backlighting to object nodes, and they are not connected to the general freeze geometry node. We could easily just connect all of these 3 to the general freeze geometry for the floor and rebake the floor. So I will unhook these backlighting to object nodes. And I will pipe all 3 of them to the first input freeze geometry of this floor setup. Now obviously we need to rebake the lighting, so I'm going to make sure to turn back the lights. And I will enable Path Tracer. There we go, I see it's enabled, it's flashed up as working. Now I can just go to the bake lighting and rebake this texture. Okay, our floor is baked. I will turn off the path tracing. Let's see if there's any other geometry we should address in the scene before we move on to other optimization steps. Now I see that we have here these 2 models representing humans. They were only necessary for pre-visualization of this project, so it would be smart to get rid of them. I will delete all of this section. Okay, with that done, I can probably just disable all the lighting as well. There we go. Now our next step should be double checking the material settings. I know that we're using quite a few here in the bottom. So all of this setup, central stage, is absolutely static. It's not animating. Though main screen, TV screens left, and moon stage are working with animated textures. So I propose we leave them as is. But then back to the central stage, we can definitely cache this material. So I just restarted the playhead. There we go. My material is cached in. That means I can get rid of all of these extra nodes, as now they are completely not necessary. And here we have side stage as well. This looks like a static material. I will cache that in as well. There we go. Let's delete the necessary nodes. Restart the playhead. Yep, looking good. So with materials cached in, and with 3D geometry addressed, I think this is a good time for us to enable the profiler. Now I'm a little bit suspicious here in this section because we have a field system and a particle system. I'm sure we can gain a little bit of performance tweaking these nodes. So let's double check the field root settings. The width, height and depth is set to 150 by 150 by 150 and is responsible for the simulation of the smoke right here. Now it's a fairly small part of the scene, so I presume we could actually drop these numbers quite a lot. I think I'm going to reduce the simulation by half. Let's preview the changes. Yeah, it looks a little bit different, but it's still definitely acceptable. I think I'm going to stick with these numbers. Now let's see the particle settings. So in the particle root, we are asking for 64,000 particles to be allocated for simulation. And in the primitive emitter, I see that we're using only 60. There is absolutely no need for us to ask to allocate 64,000 particles worth of processing power and use only 60 particles in general. I will drop the particle root setting for a number of particles from 64,000 to 64. There we go. It definitely looks like the numbers dropped both in the field root and in the particle root. That's great. Now this is a very small and incremental thing, but I see that there is a little bit of a power draw in the gradient. And this gradient is powering the point renderer. So basically this is just a circular texture for a sprite. I think we could easily reduce the numbers here. So I'll make it 90 by 90. And since this is not an animated gradient, I will turn on static image process once property. And here we are, it's definitely running faster. It's not even indicating any numeric values on the Nodegraph anymore. Right, let's move on to the lighting. And I see that there's some relatively big numbers going on here with the environment map and screen space reflection. So on the screen space reflection, I could probably reduce the blur sample number. Now this is a very rich and good number. I think I can suffice with something smaller. Let's try 64. Yep, definitely an increase in performance here. So to further increase the performance, I could probably choose specific surfaces that I want to work with reflections. There is absolutely no need to have screen space reflections on the ceiling, on these panels here, or even on this back screen right here. The only areas where I want to see some reflections is the floor. So let's find the floor node. In this case, our floor node is under the freeze geometry. So I could easily grab this freeze geometry node and pipe it to the second input of screen space reflection affected nodes. So with that done, we've gotten rid of all the reflections from the roof and side panels. And of course, the performance definitely changed. So we dropped it half yet again. Now, environment map. Let's check the settings for the environment map node. Resolution is rather high, 2048. I'm pretty certain that if we drop it halfway to 1024, the visual impact is not that great. Hence, we don't really see the big difference, but we'll definitely see a difference in performance. Can we drop it even further? 512? Yeah, we can actually get away with 512. I'll leave it at that. Okay, let's turn off the profiler to see the actual readout of the frame rate, GPU and CPU performance. So we dropped the GPU and CPU quite nicely. We're hitting more or less 8 milliseconds on GPU and 7 to 8 milliseconds on CPU. Okay, another good thing to double check is camera setting. I see that I still have a regular camera here, but in order to use this virtual production set in a media server, I should swap it out for exposable camera, because that's exactly what enables media server to attach tracking system to notch camera. So I'll right click, go for replace node with, I'll navigate to camera setting, and here I have exposable camera. There we go. This is good. And now we'll just expose the exposable camera values so that the media server can handle all the positional and rotational data. Expose property. Okay. So I'm rather happy with my geometry settings here. I am rather happy with all my textures. I've spent a moment here optimizing my field system and particles. That's good. I think this is more or less done. Yeah, all the rest of the settings looks fine. I think this is more than ready to be passed over to a media server operator. Now, if you want to test your knowledge, I left a second layer here in the graph with several traps and inconsistencies. And I will leave them for you to discover and correct. That is, of course, only if you want to test your knowledge that you've gained watching these videos. Alright, that's a lot about optimization, but I talk a lot about it because it is important. So let's wrap up the optimization section of this course with some additional quick tips. Let's start with keeping your node graph tidy. Clean it up as you go and remove nodes you no longer use. It is important to frequently monitor performance and make sure that the project runs fine at or above the final resolution and FPS requirements. Remember that overscan increases the rendering resolution. You should always move your camera around as you design your scene, because rendering speed will vary depending on what's in view. Always ground your talent. Make sure it doesn't look like they are floating in space, unless that's the look you're going for. If you have a bright scene and you are unable to ground the talent, try the rug or stool trick. Add the rug or chair to the area of the stage where the talent stands. This will help ground the talent by obscuring the bright LED floor and create a natural shadow when used with physical lighting. It can make all the difference. Now the preparation and design work is done. It's time to pack your gear, export the blocks, and head to the site. But first, let's make sure you've ticked all the boxes and your scene is running optimally for production. So, always check that the lighting is baked where necessary, and don't forget to make sure that your regular camera is replaced with exposable camera. Of course, it is smart to review exposed parameters too. And test your block, preferably in a media server, but if you do not have access to it, use Notch's own media server emulator, FX Player. So in the next workshop, let's export a Notch block and let's use FX Player to play it back. In this video, we will export this scene as Notch block and we will play it back via FX Player. FX Player is a simple media server emulator that works as a reference tool to track Notch performance and allows you to preview Notch block playback when an actual media server is not available. But before we do the export, let's make sure that we have the basic parameters that we will need in the media server exposed. Here I see we have exposable camera, not a regular camera. The positional and rotational values are exposed for media server use, that's great. And we have majority of geometry connected via null, and the positional values of this null is exposed as well. So that's good. We can actually preview all the exposed parameters via exposed tab. So here we have our exposed camera, null, and several video loaders. So let's export this scene as Notch block. Let's head to the project, compile block for media server use, and let's put it on a desktop. Okay. Export is complete. At this point, we can close off Notch Builder. So now let's navigate to the Notch FX Player and let's play back the scene that we just exported. You can find FX Player in your Notch installation folder. In my case, it's a default location, so it's Windows, C, Program Files, Notch, and there it is, FX Player host DirectX 11 64-bit. Let's open it up. And here we have a very simple UI that allows us to choose the width and height of the simulation. So I will go for 1920 by 1080. And we can load the block. And here we go. Our block is being played back by FX Player. So here at top we see basic stats of our performance. So we're rendering 8 milliseconds a frame and we are on 128 FPS. That's great. In fact, the most accurate readout of notch block performance is available via FX Player. Because when you're playing back your design in Builder, Builder allocates a reasonable amount of your resources just to be able to run. Now in this case, we're playing back only the design that we created and a notch engine. Hence, we're getting an increase in performance. Usually that mounts up to 20-25% of the actual performance visible in Notch Builder. So this is absolutely great tool to double check your performance before you load your block to media server. Now, as you see, we have a visual representation of layers. In this case, we only have one. If there were more, we could switch them. And here we have all of the parameters that we've exposed for media server use. So I usually use it to double check that a property that I need to expose is exposed and is in this list. Now you may have noticed that some of the surfaces retain videos and some has a hue rotation. These three surfaces were not exposed for media server use. However, these LED panel surfaces were exposed for media server use. So FX Player is showing off a hue rotation pattern just to indicate that this parameter is available as a variable should you choose to attach some kind of a signal in a media server. Okay, I think we are done with this video. However, we will come back to FX Player when we will be talking about network editing. Once you are on location, your design should be solid. As a notch designer or virtual production technician, the majority of your work will be in everything we've talked about already: planning, designing, testing, and optimizing. When you're on location, your focus will now shift to refining and adjusting the scenes you've created according to real-world effects like lights or changes your art or technical director are looking for. Notch has a built-in feature which thankfully makes it easy to change your blocks after they've been loaded up in a media server, and that's called network editing. The network editing tool allows you to connect a Notch Builder to a running block over a network connection. This means you can make edits from anywhere in the world and block will update in real time. It is an incredibly powerful feature and a lifesaver when doing an on-location work. Let's check it out before we move on to some practical tips to wrap this chapter. Notch Builder Pro is able to remotely edit Notch projects running as standalone or block on local or remote machines. Changes made in Builder will instantly be reflected on the remote standalone or block that is running in a media server. Let's export this scene as block for media server and use FX Player to play it back. FX Player is a simple media server emulator that works as a reference tool to track Notch block performance and allows you to previous Notch block playback when the actual media server is not available. So let's start by exporting this design as a media server block. I'm going to go for Projects, Compile Block for Media Server, and I'm going to make sure that I'm leaving it off on my desktop. I'm going to hit OK, and let's give it a moment to compile. Great, I see that the export is done. My block is available for me here on my desktop. So I think now it's a good time to navigate to FX Player and launch it. So I'm going to go for Windows, Program Files. I'm going to navigate to Notch folder. And here I see FX Player host DirectX 11 executable. I'm going to launch it. I will start by resizing this window so it doesn't take the whole screen real estate. There we go. And we can close off this window now. Okay, I think now I'm ready to load the block. So I'm going to go for load block. I'm going to navigate to the desktop and grab the very block that we exported, Simple TV Stage. Let's give it a moment to load up. Okay, so I see that the block is playing back. I have a couple of panels here available for me. And before we start network editing session, I'm going to make some changes. I'm going to reduce the resolution here a little bit. I'm going to go for 920. 518 resolution, so it fits just a little bit better here in my available real estate on the screen. As you see, I have some basic stats on the performance of the block in the FX Player, so I see the average milliseconds it takes to render a frame and the general frame rate. Since this design consists of a couple of layers, I actually can see them here in the second tab, Instances. And as you see, if there's an open parameter, that is displayed and available for use as well. Right, I think now we're definitely ready to network connect to this block. So I will go for devices, network connections, and I'm going to connect to this block. Now, if I was using this block on another machine, I would refer to the IP address of the machine that I want to connect to. Since I'm running the block and builder on the same machine, I can just leave this as a local host. So I'm going to hit connect. And here I have a selection of available blocks that can be connected to. In this case, there's only one, simple TV stage. That's great. I'm going to hit OK and OK again. And now I am in session with this block. So what is the best way to know that this connection is valid? Well, the easiest way is to go for view and enable the connection monitor. So connection monitor, it gives you basic stats of the connectivity. In this case, we see that we are connected via local host. This is our port number that was designated automatically, and this is the name of the block that we are referring to. Here in the second line, we can see the connectivity speed by bytes sent and bytes received. So once we're in a network session, we can actually make changes to our scene from builder and it will be reflected directly in the block. For instance, if I grab something like thin post effect, I can apply it in builder and the changes made will be seen in the block instantly. So not only I can make alterations to the scene, I can actually open new parameters to be controlled in the media server while I'm in a network connection session. For instance, I want to open this blend them out parameter. I'm going to set it to 0 as a default, and I will hit on a question mark icon that allows me to expose this parameter. First of all, I'm going to set the minimum and maximum value. In this case, I just need a value from 0 to 1. And let's expose this parameter. As soon as the parameter is exposed, I already see it here in my properties window. This workflow is not limited to just post effects. You can take advantage of any node available in the node list here. So I think I will add some primitive geometry. I'm going to go for shape 3D. I'm going to connect it to the root. And you will see that as I'm moving, the shape 3D is actually available there in the block and is moving together with the builder's positions. So let's talk a little bit more about the connection monitor. From the connection monitor panel, I can actually switch layers inside of the media server. All I have to do is enable the layer select, and then go to the desired layer here in builder, and hit on a switch to selected layer. All of a sudden, I am seeing the layer that I selected from the builder in the media server. So this is extremely handy if you need to preview quite a few layers running in a media server. So for now, I'm going to switch back to the first layer. There we go, switch to the selected layer. Third property available for us here is control time from builder. Now, this property is reserved to the executables. So if we were to export a standalone application, we would be able to control the playback time of the executable via builder's timeline. Now, since we're playing this back in the media server is treated a little bit different, so this property is not applicable. So let's head a little bit further and let's talk about profiling. So profiling allows you to see the performance of your nodes in the GPU and CPU milliseconds. This property is not reserved just to the builder. You can actually see the performance of the nodes in your block as well. All you have to do is enable profiling and choose network. As you see, numbers are updating a tiny bit slower, but they reflect the performance of the block and you can actually track it here in builder. Now bear in mind, since you have the profiler enabled, the performance drops a little bit because you're making extra calculation. So once you're done tracking the performance and making necessary changes, make sure to disable it. Okay, now I will switch to the second layer, test. And let's talk about track exposed parameters property. I'm going to enable it. And as you see, it indicates that I have two active instances, meaning that I have two layers available. I'm going to click on that. So with track exposed parameters enabled, I can control the exposed parameters from media server and they will be reflected in the builder. So this property is extremely handy if you're working with a tracked object or a trackable camera. Basically, you see all the real-time behaviors and all the real-time swipes that are happening in media server reflected in builder. So that definitely helps a lot if you're in a network editing session and you need to make some live changes. Now, as you see, time is not aligned in these two instances. For that, we have the last option here, track play time. As soon as that is engaged, all of a sudden, media server timeline takes over Notch builder timeline, and all the changes and animations align. There are a couple of extra things that are worth mentioning. Remote connection works over TCP/IP with each block or standalone listening on an auto-selected port. You can use remote editing over a solid Wi-Fi connection as well as wired. At the moment, all of the changes that we're making in the builder are only reflected in the block. To lock in and save all the changes you've made, you would have to recompile the blocks. You would have to go for project, compile block for media server, overwrite the block, or make a new instance that you would be able to swap out in a media server. In a previous tutorial, we covered the fundamentals of connecting your scene to media server. So let's pick up from where we left off. So let's start off by preparing the scene for on-location work. Let's establish the network connection, and let's disable the previous elements. So I'm going to head off to the devices, network connection, and I'm going to make sure that I'm connected to this block right here. As I'm running Notch Builder and Notch block on the same machine, I don't have to change anything in the connection IP address. I can just run with the local host. So here is my list of available connections. This is the very one that I want to connect to, the Simple TV Stage Lite. I'm going to connect to this by hitting OK. Right, I see that I have an active connection. That's great. So let's disable the previous elements. So I will mark up the whole bracket and I will click Ctrl+1 to disable it. It is gone from the builder viewport and it's definitely gone from the block. So previous elements are definitely gone. But if I preview the stage element, I will see that in a light bake, there are still markups of those elements baked in. So I should definitely rebake this stage element. In order to do that, first of all, I have to enable the dynamic lighting. So here are all the light fixtures that I should enable. So I'm going to click Ctrl+1 to make sure that they are running. And I see that I have Path Tracer in the scene, but it's disabled. So I can enable it by clicking on this UI icon or using shortcut Shift-R. And as I see in the root node, now it is definitely enabled. Great, so the dynamic lighting is working. Let's come back to the stage element and let's rebake it. So I'm going to click on a Bake Now property. I'm going to double check the settings. I'm quite happy with the 200 refines and I'm going to click OK. If you're interested in learning more about the basics of light baking and best practices while doing so, please check the tutorials that are listed below the video in the video description area. My colleague will host a number of them covering all things one needs to know to get up to speed with light baking techniques in Notch. So when does light baking via network connection come extremely handy? Well, say our art director wants to see the stage element a little bit smaller and a little bit further in the back. Let's address that. There we go. So we made the necessary change, but as you see, the light bake of the floor does not align anymore with the stage element that we have. So we definitely should rebake the floor. And as I see, all the floor elements are connected to this freeze geometry node, and it's all baked in with this bake lighting node. So let's rebake it. As you see, this workflow is non-destructive, as it does not break the overall scene and it does not require you to rebake the whole scene every time you make changes. Bake lighting over network connection technique allows you to do incremental changes to all separate elements, until you get your scene to a point where you're ready to film. So once you're done making changes to your scene, make sure to disable all the dynamic lighting. And recompile the block for media server. As at the given moment, we're only reflecting changes made in Notch Builder to a Notch block. So I'm going to go for Project, Compile Block for Media Server, and I'm going to make a new version of this block. Depending on the media server you're using, you might be able to overwrite the setting, or you will have to do a new increment. In this case, I'm just making a new version. Compiling is finished, so I'm going to go for Devices, Network Connection. I'm going to disconnect from the block. And I will reload the block to a new version. I see that the new block is loaded. This scene is ready for the shoot. So let's go through some practical tips for on-location work. Start with making sure that virtual lighting is aligned with the physical lighting of the stage. Then check your scene to see if you can delete props that are no longer needed, based on changes from the director or camera placements. And lastly, do some finishing touches on your optimization. Cache all static materials, but do this as an absolute last step before shooting, as this process is currently destructive. Keep a copy of your non-cached materials in a backup the effects if needed. Make sure to reduce the number of dynamic lights if you find out you don't need all of them. And reduce the number of objects affected by reflections. If you have many objects and virtual lights, calculating reflections can be expensive. If you don't need the reflections, bypass them in the Nodegraph.